Hello, my name is Rene Zaumseil, and I would like to present a real-life example. I will show you our simulator Instructor Station. It was built using TCL/TK, SQLite, the graph and path widgets, and zipkits. At first, I would like to show you an overview of our simulator. We have the running simulator. It is calling all the models and it calculate process and new logic states. Then we have a connection via SQLite to our instructor station to set and get data, live data from the simulator. And the instructor station is using an SQLite database with all the data that are needed. In this database are roughly 2.5 million variables and constants. We have 80,000 mail functions. We have 16,000 process and control drawings. And from these drawings are the simulation models built. We have a panel with roughly 20,000 IO variables, and we can add up to 3,000 variables to our archive. And we can also connect our process computer to the simulation. The simulator is running with a cycle time of 250 milliseconds. That means in 250 milliseconds, we have computed the new state of all the models. And we can run it on dedicated hardware with a fast mode factor up to 5. The archive functionality is built using SQLite. We have, in fact, two databases. The first database is a configuration database. Here we can add and delete variables from the instructor station, and the simulator is just reading the variables, and then it will send the current data of the variables in the archive database, and we read it from the instructor station. We have to take care that the simulator is running and it is not waiting on some action. So we have used the val mode to write the variables into the database. It was a little bit tricky to clean up the archive database. This is needed when we load a new initial condition and we have to delete all the data. We found out that when we have many data in the database, a drop table takes too long. So we have to schedule the drop, and we just rename the tables and drop it afterwards.
Hi, Renee. I'm sorry to interrupt just a moment. Can you maximize this PowerPoint for us so we can see it a little better?
So
it's just at the bottom of there.
Better?
Actually, no. If you just want to hit that little PowerPoint maximize box, it's next to the X. Yeah.
This one?
Yes, that's perfect. Thank you.
That one? Okay.
Yeah.
Better. Good. So, yeah. Next one is the application building. We are running Windows 10 and we're using as compiler an MSys MinGW. We use TCL/TK 8.7, PDF4Tickle, SQLite, TableList, and TKO. TKO is an extension which contains a graph and path widget. When we start building, we have two steps. The first step is to build the TCL shell, the wish, and the binary extensions. When these data are not available, we set up our MSys MinGW system, and we call the zipkit shell script to create these extensions and tickle shell and wish executables. In the second step, we use a new zipfs program from TCL/TK7. and we create from the binary extensions and from our source data our executable, and it's roughly 10 megabytes big. We use in our code a naming convention. We are from a power plant, and the power plant has already an existing naming conventions, and we also name our variables after these naming conventions. We use one class or namespace per file. When we start up the application, we create all the needed images is will in a naming convention again. In this naming convention goes after the directory structure where the images are contained. We have an OO extension with private variables and option handling and traces. I think we will try to replace it with the private variables now in the Tickle OO package, and we will use the option handling from the TKO package. Then we have some helper functions for accessing files and directories. We have an extension option to better deal with extensions. We have an extended grid command. In this command are the row and column configure options included, and we can add scroll bars and tooltip options to this command. With the menu and menu bar commands have we extended to create our menus and menu bars from a common dictionary. All the text messages displayed are also defined with a common pattern, so we can extract this pattern from the code, and then we can edit all the patterns to add the needed translations. We have also a function to display the matrix of our code, so you have a feeling how much is it. Now let's start the real example. Here is our instructor station. I've already loaded an initial condition, and now we can run it. And we can add some mail function. Here is a table list widget. It has roughly 80,000 entries. And I will add a mail function containing a short circuit of our net. Here are the current data, and after 10 seconds, we should see some changes in the data. It's now. So you can see it is live. For our instructors, we have on the full scope hard replication of the real control room. But we have some more simulators, and for these simulators, we have just a soft panel like here. This is a room normally used for the instructors, and these are the rooms where some auxiliary control rooms are located. We also have some parts which are not contained in the hard panel simulators. They are only exist here on the soft panel. Now let's have a look on our panel. This panel is implemented using the pathwidget. You can scroll here. This panel has roughly 12,000 elements with 2,500 binary in and outputs and 400 analog outputs. And it's possible to just zoom in and out. Then I can show you some recorders on the simulator. Also here you can go in and out, and it scales Also the texts are scaling. Then we have some special items on the panel. One of these is a control road display. This is in the normal panel panel. On the real plant, is it a computer with a monitor, and we have added it here also in the path widget. Another special item are the emergency diesels. Here we have also an extra computer. It's a WinCC computer, and we can also use it here in our soft panel, like in the normal plant. Another application is our core display. Here you can see all the simulated core levels and all the data points in each level. And it's also a live display. You can see it here. Oops. It's running. We have roughly 12,000 analog outputs here. As already mentioned, we have some drawings in the simulator, and from these drawings the code is generated. We can show these drawings also here. This, per example, is the electrical network plan of our drawing, of our plant. This plan has also roughly 25,000 elements and 1,000 variables. And if we connect to the simulator, we can animate these variables. We also have some control models. It's always possible to print the current drawing with the current state. And we do it by creating a PDF file. And I think here you can see it's PDF, and it's not just a copy of the screen. To make maintenance of the simulator easier, we have a maintenance application here. In this application, it's, per example, possible to compare some running some tests, the output of some tests. And I have here the output from our current year, and I will try to compare it to the output from last year. And it's using the graph widget. Here in the graph widget, we have two independent XY axes, and we can display the data one over the other. And it's possible to see differences between different runs. We also can maintain our panel application with the maintenance application. We can start the panel mode again and can, per example, change this application. Just to show you, I will change the color of these lamps, and you can see it's working here. Another one we can. Okay. I have already mentioned that we are using a special naming convention for messages, for our messages. And if I start the application in this special mode, this is necessary so we can access the message catalog files and can write back these files. And here I just parse all the source code files and get all the message strings. And here not translated strings are marked with 2 question marks, and we can easily change the translation. Okay. The conclusions, all the stuff you have seen is developed with just 5 man years. We have used C extensions for fast code and to access the RPC library to connect to the simulator. And we have done all the other parts in TCL. We have used some little helper functions to make our life easier. And I think we have a maintenance friendly mode. We have a single file executable, and we have a single file SQLite database. And to add or install a new Instructor Station, just these 2 files are necessary. We mostly generate on the fly our data, and we can print with online generated PDF files. All the needed tools for our maintenance are included in this application. Thank you for your attention, and please ask your questions.
All right, if anyone has any questions, if you could please submit them on the Q&A. Okay, we do have one, Rene. You want to pop that little screen up and stop sharing.
Stop share. Yeah.
Perfect.
Q&A. Yeah. Yeah. From Harald Oehlmann, is zipkit from TCL 8.7? No, zipkit is just a shell script, nothing else. And it's using TCL 8.7 features. You cannot use it with 8.6. And I create PDFs with PDF4Tickle. Anything more? No, seen what's. I don't have used the TK Pass extension. Originally, I have used it, and I think the last version is still included in Antrovish. I have made some tips to include it in TK. You can find it in the tip fossil, and it was not approved, so I have separated it and put it in a separate fossil repository, and I think it's still on one of these pages of my presentation. You can find the no, Tilman Basian. I don't use any IDI for the TK graphical user interface, I use extended grid command. So you have you can put all the options needed for an widget in just one line. Hmm? No, I don't use Tilman Basian. No, I don't use an IDI. My IDI is Vim, the VI editor. Maybe one thing which is still missing in Unix build is the use of the console. I use it for developing and testing new features often. Holger Jacobs, what is the advantage of zipkit? I have used or I have developed it because I would like to get rid of the old code from Jean-Claude Whipler from Flirk and VFS and zeplib, which was needed for building tickle kits. And with TCL TK 8.7, we have all the needed components already in the TCL shell. So it's less code. Holger Jacobs, is there a link to it? I think you can get the PDF of the presentation and there is a link. It's a link to the zipkit and the TKO, and I think you can also find it via the wiki. Yeah, both zipkit and TKO included in the wiki, I think.